Okay, so in this video, I'm going to show you some examples of finding derivatives that involve trig functions. So today in class, we came up with these 6 rules for derivatives of trig functions. And now I'm just going to show you how to apply these rules to finding derivatives. But first of all, let me just say that it's important that you study and know these 6 rules, because the better you know your rules, the easier this will be, okay? And remember, there are some tricks to help you remember. Some of the things that help me is that if the function starts with a c, then I know the derivative is negative. I always remember that like sine and cosine are each other's derivatives. I remember that like tangent and cotangent have the squared derivatives. So derivative of tangent is secant squared, and derivative of cotangent is negative cosecant squared. And then I always remember that for secant and cosecant that the derivative starts with itself. Okay, so derivative of secant of x is secant of x tangent of x. Derivative of cosecant is negative cosecant of x times cotangent of x. So anyway, that just helps me keep these straight. But let's look at some examples. Okay, so if we want to find the derivative of this function, first of all, we are finding the derivative of a difference because we're subtracting the 2 functions. And so in that case, we can just find the derivative of each term, okay, and add or subtract. And the 3 and the 10 are just constant multiples. So this derivative is pretty easy. G prime of x would equal, 3 is a constant multiple. So we'll just bring the 3 down, multiply it times the derivative of secant of x. And the derivative of secant of x is secant x tangent x. And then minus 10 is another constant multiple, times the derivative of cotangent, which is going to be negative cosecant squared. So subtracting that negative will change this to a plus cosecant squared of x. And you guys, sometimes you'll see the x in parentheses like we do in the original problem, and sometimes you don't. I don't usually use parentheses if it's just an x, but if it was something like secant of 3x, then I would use parentheses. But if it's just an x, to me that gets a little too busy. But yeah, there's nothing wrong with putting parentheses around the x. All right, let's look at another example. All right, so you guys, this time our function is h of w equals 3 times w to the negative 4 power minus w squared times tangent of w. So when I look at this, I can tell, like, for the first term, we just need to use power rule. But for the second term, because we have w squared times tangent of w, this will require product rule. All right, so again, just my best advice is take it step by step. Okay, so to find the derivative of 3w to the negative 4, we're just using power rule, so that would become negative 12 times w to the negative 5 power. Okay, minus, and now we got to do product rule. And I'm going to put product rule in parentheses so that I don't forget to distribute my negative later, okay? So let's look at product rule. So, and again, you guys, if you want to use that trick, I really like it. This is where we'll just write the 2 functions separately, find the derivatives of each underneath. So derivative of w squared is 2w. Derivative of tangent, we now know, is secant squared of w. And then you can just do like a little cross multiply. Okay, so we'll end up with w squared times secant squared of w plus 2w times tangent of w. All right, then as far as simplifying goes, let's go ahead and distribute our negative. So we'll end up with minus w squared times secant squared of w minus 2w times tangent of w. And honestly, I mean, the most I would maybe do after that is we could get rid of our negative exponent and write the first term as negative 12 over w to the 5th power. But other than that, I would stop right there in terms of simplifying. All right, moving on. Okay, now let's look at this one. This time we have y equals 5 times sine of x times cosine of x plus 4 times cosecant of x. So I don't have to worry about these constant multiples because I can just bring those down in front of the derivative. But this sine times cosine, that's going to require a product rule. Okay, so let's just start with that. I'm just going to work that off to the side. So our two functions are sine of x and cosine of x. Find the derivative underneath. Derivative of sine is cosine. Derivative of cosine is negative sine. Cross multiply. So sine times negative sine is just negative sine squared. Plus cosine times cosine is cosine squared. So to find our derivative, dy dx, we'll bring the 5 down in front. Okay, times our product rule. So, and you know what? I think just to make it look better, I'd probably just rewrite this as cosine squared minus sine squared, just so we're not leaving off with a negative. Okay, plus bring the 4 down as a constant multiple. And then the derivative of cosecant is going to be negative cosecant times cotangent. So because of that negative, our plus will end up being a minus 4 times cosecant of x times cotangent of x. All right, and then we could distribute the 5. So we'll have 5 times cosine squared minus 5 times sine squared minus 4 times cosecant times cotangent. And, you know, as far as simplifying, if we could maybe simplify with our trig identities, that is always a possibility when we're using trig, but like I'm noticing the cosine squared and sine squared, but unfortunately we're subtracting, so I can't really use my Pythagorean identity there. And then I was quickly thinking, well, cosecant times cotangent, could I simplify that? But cosecant is 1 over sine, and cotangent is cosine over sine, so that would just become cosine over sine squared, which, I mean, isn't really that much simpler. So I think we will just stop right there. Okay, now let's look at an example with quotient rule. So here we have sine of t divided by 3 minus 2 times cosine of t. So because it's a quotient, we're going to have to use quotient rule. Okay, so p prime of t would equal, start with the bottom, low, d high. Now the derivative of sine, remember, is cosine, minus high, which is sine of t, d low. Now, the derivative of 3 is 0. Okay, the negative 2 is a constant multiple, so I can bring that down in front of the derivative of cosine. The derivative of cosine is negative sine, so actually that will become a positive 2 times sine of t. Okay, all over 3 minus 2 times cosine of t squared. Okay, now as far as the numerator goes, I would do like we did in the past. We could distribute the cosine, so we'll get 3 times cosine of t minus 2 times cosine of t. Excuse me, minus 2 times cosine squared of t, because cosine times cosine is cosine squared. Okay, and then minus sine times sine is sine squared. So this will all become minus 2 times sine squared of t. looking like we maybe could simplify this one a little bit with our Pythagorean identity. I am kind of noticing if I group these two terms together, I could factor out a -2, and that would leave me with 3 times cosine of t minus 2 times cosine squared t plus sine squared t, all over 3 minus 2 times cosine of t, all squared. Okay, and then remember cosine squared plus sine squared equals 1. So this would all just equal 3 times cosine of t minus 2, all over 3 minus 2 times cosine of t squared. So that did simplify a little bit by using our Pythagorean identity. All right, so we've seen some examples where you had to use power rule, product rule, and quotient rule in combination with our trig derivatives. So now I want to talk about chain rule with these trig functions. So I have an easy way for you to remember chain rule with trig functions, and it's called ETA. So the E stands for exponent, T stands for trig function, and A stands for angle. And so this tells you the order in which to find the derivatives, okay? Because remember, chain rule is a way to find the derivative of a composition. And sometimes with these trig functions, we're dealing really with 3 functions, so it might be like an f of g of h scenario. So this is kind of an easy way to break it down. So the idea is you find the derivative of the exponent, keeping everything else the same, times you find the derivative of the trig function, keeping the angle the same, and then you always wrap it up times the derivative of the angle. Let me show you an example. Okay, so in our first example, we have y equals sine of 3x. Now, why is this chain rule? Because it's not just sine of x. If our function was just sine of x, we would know the derivative is cosine of x. But it's sine of 3x, so the 3x has been plugged in for x, making it a composition, okay? So with our ETA, since this is one where we can actually skip the exponent because we don't have an exponent here, like we do in some of the other problems, see the exponent cosine is cubed there, or like here tangent is squared. So here we can actually skip the exponent part, and we can go right to the trig part. So I'll just start with the t in ETA, and dy dx would end up equaling derivative of sine is cosine, okay, of 3x, keep the angle the same, but then times the derivative of the angle, so then times 3. And then to simplify, we'll just put the 3 in front of the trig function. So we get 3 times cosine of 3x. Okay, so that was one where in the ETA we could skip the E part. Now in our next example, we have y equals cosine cubed of x. So this is one where we're actually going to start with the exponent, and we're going to bring the exponent down in front. So this is just power rule. We're going to bring the 3 down in front, and we're going to subtract 1 from our exponent, okay? But we're not finished. We then have to multiply by the derivative of the trig function. So derivative of cosine is negative sine. Okay, so this is our E part, this is our T part, and now our angle is just x. So the A part would be the derivative of x is 1. So I'll just use parentheses here. So there you can see the ETA. Honestly, we could have skipped the A part, but just so you can see that whole the way that works out. And then as far as simplifying goes, I would just, since we're multiplying everything, write it as -3 times cosine squared times sine of x, and we're done. Okay, now let's look at G. Okay, so G, again, think ETA, we're going to start with the exponent. So we're going to bring the 2 down in front, subtract 1, so that'll become to the first power. But notice how I'm keeping everything else the same. Okay, but then times, now we're going to find the derivative of the trig function. Derivative of tangent is secant squared of 2x. Keep the angle the same. But then we'll multiply by the derivative of the angle. Derivative of 2x is 2. So again, you guys can really see why we call this rule chain rule, because you really end up with a chain of factors. And you know, keep in mind we're like multiplying these three things. Sometimes I like to use the dot, sometimes parentheses. But as far as simplifying goes, we can multiply the 2 times the 2, and I probably just move that up front and write it as 4 times tangent of 2x times secant squared of 2x. Okay, let's just look at a few more with chain rule or ETA. So in example H, again, find f prime of x. We'll start with the exponent, which is the 2. We'll bring it down, subtract 1 from the 2, so that'll be a 1. But notice again, I'm keeping everything else the same. Okay? So that's the E and the ETA. Okay, the T in ETA is you find the derivative of the trig function. Derivative of secant is secant times tangent. But notice again, no, I'm keeping the angle the same. So it's the derivative of secant of 3x is secant of 3x times tangent of 3x. Like you just got to keep the angle the same. But then eventually you'll multiply by the derivative of the angle, which is 3. Okay, so again, this is our ETA. Okay, as far as simplifying, we can multiply the 3 here times this 2 and just write it as 6. And then the secant times secant, we could write that as secant squared of 3x times tangent of 3x. All right, let's look at this last example. Ooh, this is a marker. Okay, this is like a f of g of h of j. We've really got like 4 different functions going on. But again, just break it down, okay? We're going to start with the exponent, the 7. Okay, we're going to bring it down in front. We're going to subtract 1 from the exponent, but I'm going to keep everything else the same. Okay? All right. Times. Now we're going to find the derivative of the trig function. So derivative of sine is cosine. But again, it's going to be cosine of 3x. Okay, so I've got to keep this part the same. Okay, then times the derivative of cosine of 3x, which I would go, okay, derivative of cosine is negative sine of 3x. And then eventually times the derivative of 3x, which is 3. So, whew, this one was interesting. Okay, now again, as far as simplifying goes, we can multiply like this 3 and this 7 and this negative 1 right here. So that'll just end up being negative 21 out front. But then that's really about all we can do. So the rest I would just bring down. So we've got sine to the 6th power of cosine of 3x. Okay, times cosine of 3x times sine of 3x. There we go. Whew, that was a lot, but that would be your derivative. So anyway, I just wanted to kind of throw in one kind of a challenge problem. But again, just highlighting why we call this rule chain rule, because you really do end up with a chain of factors. So, all right. Well, anyway, you guys, we'll definitely practice this some more in class. But please study these 6 derivative rules. It is super important that you know them. because it will make your life so much easier. All right, you guys, as always, thank you for watching and have a good night.